All right. Well, okay. I may be back. Um, so if you're seeing this, then I guess what happened was the power went out, and when it went out, it of course killed the router, and so that's why I wasn't able to. Well, that's why the internet stopped working for a few seconds there, or minutes there. So I think I'm back. It says I'm. One thing says I'm streaming. Oh, and Bianca says I'm streaming. So hello and hi, welcome back. Yeah, sorry about that. I don't know what happened. I mean, literally just the power went out. Okay, but we're back online now. So what I was doing was trying to understand what this function does. This ngrams to quick dict, and I think it just tells us where to find the index of keywords. So it's a utility function, and it's not super interesting as a function, but it tells us where the halfway point is going to be. Okay, so I think we're good there. Let's try this out a little bit. So okay, so this is good. This is their kind of self-contained test of that. So let's try this out. We don't need to import OBO because we're not using that. And they're making a test that's a complete standalone here. So let's try this standalone test converted for our environment and our situation. So I'm going to clean up some of these. I'm going to clean up this one. I don't need this one. And I think I'm going to have to reconnect my runtime. I also don't need this anymore, but I will leave that one there because that's going to be the beginning of my actual code. And this is their code. So this case, it's working with test as a string. This test sentence has 8 words in it. And it wants us to get the 5 grams from that sentence. And then for the 5 grams, try and figure out where the keyword position is supposed to be.
Just let me know if I need to
Okay.
stop.
So that was my wife. She's going to be trying to do a piano lesson at the same time, and she's doing it through same kind of thing I'm doing here. So we'll see if the internet can handle both of us streaming at the same time. Okay, so let's see what this is going to do. So this should give us the the number 2 because it's asking for the index position. This is going to, let me just kind of narrate through what these 3 lines of code are going to do, hopefully. So this is not dealing with Chesterton at all or any given text. This is pretending this is the full text here. This test sentence has 8 words in it. And this line here, my line 2, is going to extract the 5 grams from that sentence. So that should be a 5 gram called this test sentence has 8. Another 5 gram of test sentence has 8 words. Another one of sentence has 8 words in. And then finally has 8 words in it as the last 5 gram. So what it wants to know, this particular function wants to know, given a 5 gram, what is the index position of the keyword of that 5 gram? And what we're defining as the keyword is the middle word. That's what this function means. So that should give us a 2. If this were an 8 gram, then actually I don't know what their plan is for dealing with even numbered ngrams, but let's just run this to make sure that it is actually 2. And it is. That's good. It's often useful to predict what you think something's going to be and then run it and then figure out what it actually is. And then if you have a different thing from what you expected, then that's a chance to revisit your assumptions about it. Okay, so far so good. I think I'm getting what they're doing here. Hopefully this is helping you as well. Hopefully you're following along. Now let's see. Now that we know the locations of our words, let's add everything to a dictionary that can be used to output all quick ngrams of a particular keyword. Study this code and then replace your ngrams to quick dict with the following. So this is taking that same function and expanding it to do quite a bit more. So let's look at what it's doing. First of all, it's going to figure out the key index, which is what we just did. That's all it did. It's going to create a dictionary called quick dict, and that's what it's this structure here of making something empty with curly brackets. That's going to set up a new data structure of a dictionary, and it's going to be blank to begin with, so we haven't put anything in it yet. And then it's going to go through each ngram, and this is a for loop, so as it loops through it, each iteration is going to be named k while it's running through it, and it's going to go through all ngrams. So it's going to be, for this sentence here, it was, what was it, 4 or 5 grams? It's going to run through all of whatever they are. We don't need to know ahead of time how many. And then if the key, if we, so key index is going to be looking at the keyword of each of those ngrams in turn. And if we already have an entry for it, we're going to just add this ngram to the list of ngrams for that keyword. But if not, we're going to create a new entry for that keyword and then add the list of that. Kind of hard for me to, like, talking through probably doesn't make sense. So let me try to work through it in an example. And I'm just going to take their version of the quick dict function and put it in place of my shorter one. Make sure to run that so that it saves that meaning of that function. My kids are doing something. I don't know what they're doing. They're stalking around. They look mad. I don't know what's going on. But they're checking on the bird feeder, I think. Okay, so a little distracting, but that's all right. So that's our new definition of the n-grams to quick dict function, which we tried out here. Let's see what they want us to do next. Okay, so it's basically just explaining it. A for loop and an if statement checks each n-gram to see if its keyword is already stored in the dictionary. If it isn't, it's added as a new entry. If it is, it's appended to the previous entry. We now have a dictionary named QuickDict that contains all the n-grams, sortable by keyword, and we can turn to the task of outputting the information in a more useful format as we did in this other lesson. Okay, let's see what happens if we do that. So this code should actually still work, but it should have a different output now because that function is different. Let's find out. Oh, great, yeah, it works. So this view of it is a little bit tricky, I think, because it's sort of flattened. If we do it like this, I think it'll print it a bit more easily to read. Yeah, instead of printing it, if we just display it. So this is, they're not in order, but my son likes to scream. That's what you're hearing. He's just playing, but that's if you hear screaming in the background, it's just Daniel. I don't know what he's chasing his sisters with a bike. He's like carrying a bike and chasing them around with it. I don't know what the heck is going on. Okay. All right, this is pretty entertaining, actually, watching them. So this is the dictionary. So the dictionary entry for the entry words has 8 words in it. So that's that 5-gram right here. Words is the key for that one, and so it has 8 words in it. This isn't very interesting because there's no repetition, but once we get to a longer example, we should see a much more interesting list of things. So let's see if we can try that out with the word list up here. So instead of running it with this test string, let's try running that with the that froze. Let's try running that with the Chesterton word list. So instead of splitting it right there, let's put the word list here. This should give me a very long list of 5 grams and then convert that into a dictionary. So let's find out. Now this may take a little time. I mean, this is actually a fairly intense computational thing. And I actually printed it all out. I didn't really want it to do that, but that's okay. Let's just, it looks okay as it was printing there, but I don't actually want it to print because that's going to be a very, very long list. So I'm going to break that out. Let's see. So let's save that instead. Let's save that dictionary into this variable called Thursday Dictionary. Hold on a second. Daniel, hey, come over here. Try not to yell so much near the sunroom. It's interrupting my video with my students, okay? Try not to scream so much. Or if you need to, try to do that in the front yard. Try to do that in the front yard if you need to scream at somebody. Okay. I'm back. Just making sure this is still working. Okay, I think it is. So anyway, so I've now saved all of the 5 grams of The Man Who Was Thursday into this dictionary called Thursday Dictionary. And just like a regular dictionary, we can actually look up the 5-gram contexts for any specific word within here. So let's try it. This is how you would call it with a, let's just actually do it. No, yeah, okay, I'm making a new cell. Thursday dictionary, and then if I want to look up a particular word within that, I can put it here in these brackets. Let's just try the word best, because that was one of the words from the other one. Yeah, okay, great. So now we have, looks like a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 5 grams. These are all 5 grams in which the word best appears. And so you can see that for each of these, best is the center of those 5 grams, or the middle word of those. Let's try another one. Let's try the word Thursday. Quite a bit more, and obviously that's the title. It becomes the name of the main character. This guy accidentally becomes part of a secret society, and he is given the name Thursday by this group, and he doesn't want it, and it's weird. I think there was a balloon in this. Let me see if I'm mistaken. Yeah, no, there was a balloon. So there's this strange thing. Let me see what else. I thought get some dinner, we must. Yeah, so now we have a bunch of 5 grams. Now, what do we do with that? That remains to be seen, but that's the completion of this essential, I guess, tricky part of this tutorial. The next part is outputting in HTML, and so we want to make it look nice, like we see here. And we can certainly do this in a Python notebook, and you should probably do this or something similar for your project if you're going to be using keywords in context or 5 grams or n-grams of any sort. So let's take a look at how this is supposed to work. So this is their example code, and let's see if we can work our way through it. This is building off of some of the things that they did already, so some of which we need and some of which we don't. So let's see. They are making a list of 7 grams here using the Old Bailey Online still, and they've got a function called webpage to text URL that they're using to convert that to text, which we don't need because we already have text. They are also using strip alpha num, which we do have, to turn that into a word list. And then they are running the n-grams, and then they're printing it. So all they're doing here, what they're doing here basically just replicates what I just did. Sorry, let me switch tabs. This code right here in their example so far, it just does what I did here. Let me make that back to something a bit more, or just to kind of use the same word as them. Let's use black, see what that looks like. So that's the 5 grams, but that's the same idea so far. Quite a lot of 5 grams. And yeah, it's not, as it says, not very readable. Like, it's still just a kind of a data structure looking thing, but we can make that look prettier. Let's try it. So let me see what this example is doing. This is asking us to do a couple of things. This is, I don't know why, this is using the slice method again. I don't really know why we need this again, but this is something that, yeah, this basically reviews the idea of slicing. So we can try it, right? Might as well. So remember the way that they've printed these things here. This is the code that we run, the part I have highlighted now, and then this 7, that's going to be the output of this code if we get the same thing as them. So let's just try this in a new section down here, which will get 7. That's saying take this sentence, split it into a list of words, and tell us how long that is. And that's what it is. It's 7. Okay. This is using the floor division method. So this is going to ask us, it's going to create a number called key index. That's the floor division result of the length divided by 2. So that's 3. That makes sense. And now we want to know using the slice. Oh, this is useful. Okay, we're using the slice method now to pick everything that occurs before the position we've identified. So that should give us amongst them A. Now this means, so the key thing that's doing all the work here is this colon. The colon is saying, like normally a slice says take a subsection of a list, start here and go to here. And if you don't have something at the beginning of that, then it just takes everything up into the point that you're interested in. And if you just have on the after side, it'll do the opposite. So in this case, it's getting everything up into the item with index 3. Or we can do the opposite. Okay, so let's see what happens. Now that we know how to find each of the 3 segments, we need to format each to one of 3 columns in our display. The right-hand context is simply going to consist of a string of terms separated by blank spaces. We'll use the join method to turn the list entries into a string. Okay. I don't know why it says parse error. That seems like it's working to me. All this is doing is taking a list and turning it back into a string and using a space character as the thing to stick them by. So join is the opposite of split, and we used split back up here to split every time a space character appeared. Now we are joining that list back into a string by using a space character as our glue. So white space padding, this is going to be a little bit interesting. How are they going to do this? Finally, we want the left hand. Okay, so we want, sorry. I have never heard of this. Okay, we want the keywords to have a bit of white space padding around them. We can achieve this by using a string method called center, which will align the text to the middle of the screen. I had never heard of that. We can add padding by making the overall string to be longer than the keyword itself. The expression below adds 3 blank spaces, 6, which is 6 divided by 2, to either side of the keyword. We've added hash marks at the beginning and end of the expression so you can see the leading and trailing blanks. Okay, interesting. So I've never heard of the center function. Let's see how it works. Pretty neat. So these hash marks here, they've just put in as comments or they're being displayed as comments or flags to show you where there is white space. If there's not trailing, otherwise the trailing white space would just look like you wouldn't be able to tell it was there unless you highlighted it. So that's all they're doing with those. But that's interesting. Okay. And we can add it on either side, so that's fine. Okay, so this is all going to be put together into a function called pretty print quick, and this is doing all those things that we just saw. It's going to be, yeah, kind of combining all these things. This is all, I think this is just useful as its own. Even if you didn't really follow how this was built, I think this is just going to work as it is. So I'm going to take this function here. This is called pretty print quick. I'm going to put it into my function definition area. What? That one's Zotero. And now, how do we use this? Let's see. Stop doing that. What? What is? Okay, I'll come check in a little bit. Thanks for telling me. Okay, sorry. So this is the part we can actually use this. So we can, yeah, this is all being constructed in a way to generate HTML, which we don't really have to do. So I'm actually not going to. Let's just try. Yeah, I think we can adapt this. So let's go ahead and adapt this code here. I'm going to have to change some things to make this look nicer, but let's do that right here. So target black, that's just the word that we're looking for in this case, and it should give us a version of the same list that we printed before. Outstring, we don't really need to start that with a pre-tag because we're writing in a context that's going to be pre-formatted anyway. So if target is in the word dictionary, do we have the word dictionary yet? We don't, so we need to define that. Word dict is what they called the same thing that I did earlier where I made Thursday dictionary. So I can just run this like that. No longer need that output. And when I'm done with this, by the way, I'm going to put all this together into a nicer package so it runs all at once, and then we'll be good. So I don't need OBO, but I do have pretty print quick K. Let's go ahead and output a blank line instead. Okay, so we're constructing something called outstring, which is going to be the answer, and then I think we just need to print it. They're doing something fancy to make it HTML, but we don't really need to. Nice. Hey, all right, that looks pretty good. Now, as far as drawing conclusions from this is something that, of course, takes a little bit more work, but it's interesting that with a black beard and with the black beard both appear near each other in this list. So, So that's pretty nice. I'm going to go ahead and I'm going to keep talking to kind of tidy this up a bit to make it actually a useful thing in case you want to do this. You can just take my code and use it. But otherwise, I'm going to wrap it up pretty soon. And Dana was just telling me that the refrigerator isn't working right now. It's turned off for some reason. So I might need to go reset a fuse or something. But let me go ahead and do this. So let's say that I want to do this for Chesterton. Let's just say I want to do this for all of his books altogether, right? I could totally do that. Let me just build this out this way. So this is get the text files from the corpus. This is the files. And I'm going to add some explanatory comments in here, or rather text cells. So I'm going to add all of these text files into a single word list. This is similar to what Shannon was asking about the other day. So I need to make this a for loop. So we'll do for file and files. Then I do something like this with open file r as f text equals f read. I'm going to go and make an empty word list up here. And I think I can just do a plus sign to combine lists, but I don't know. We'll try. I sometimes run into issues with this kind of thing, but if this works, then what it should be doing is going through each of those files. I think there were 5, and then for each of them making a word list, but then adding it to the massive word list. So let's see if this ends up working. Did it work? I guess so. It didn't report any errors, so I guess that worked. Let's just kind of see. Okay, so I don't need to run that code anymore. So I'm going to leave that alone. You know what I'm going to do? I'm going to actually make this all... This thing is so slow. Instead of putting cells like that, I'm going to make this one... I'm going to make it easier to work this as a complete program. So I'm going to make this an actual code comment so that I can just move this all together into one cell later on. Next, we work through each of the text files, adding each to the master word list. Okay, that seems to work. And I don't need this cell anymore because that's been replaced by something else. This was just a test, so I don't need that anymore. Okay. Transform that massive word list into a dictionary of engrams. I'm missing something. What am I missing? I have not actually engramified it yet. I need to get engrams. And let's go with 5 grams. So I'm going to be running get engrams, saving that as a value called engrams, and I'll run it on my variable called word list, and I'm going to give it the argument 5, and then that's going to give me 5 grams. Okay, and then okay, I guess this worked. And then now the word dict is going to be constructed from those engrams. This should take a little bit longer. No, it didn't. Okay, so now this code actually should have everything it needs to run for that one, so that's great, except it's a lot more than black in this case. I mean, there's a lot more blacks now than the ones that were there just for the man who was Thursday, but that seems to work. Okay, so let me move all these into a single cell to make this even tidier. And then I'm going to make one more change to it. I'm going to move that somewhere else too, but let me get rid of some extra cells. And I know I've gone a little bit long, but I had some interruptions, and I'm almost done, so bear with me. So now this is all looking more like a Python script, more like a lot of things happening all at once. So let's do a couple things at the outset here. Target equals, let's just say Thursday again, and in equals is going to be, that's going to be the size of gram that I'm looking for. So let's do it with, I did it with 5, let's do it with, I don't know, let's do it with 3. I don't know what that's going to be. I think odd numbers are going to work better, but let's try it. So now that I've created these two things, like it's easier for me to change it once every time I want to run this and see what happens. So now I need to go through and change any place where I was referring to the in size, and that's I think this is the only instance of that. And then target is defined at the outset and then just used down here. So this should give me, so this is all of those different chunks of code now put into a single cell that should just run. Let's see. Yeah, so it looks like it worked. So these are Thursdays from other texts as well, and that's pretty useful, I suppose. If I wanted to, I could probably restructure the dictionary a little bit so that I was not just seeing the engram, but I was also seeing which file it occurred in, and maybe sorting by the different documents might be interesting. But that basically does seem to work. So, what's up?
I didn't do the fridge thing.
I will take a look at the fridge. Just let me wrap up here. Okay. All right, everyone. So it looks like I lost some viewers. I'm down to 4, but hopefully that's was helpful to the 4 of you. Or hopefully you're able to find this useful if you're watching it later on. So I'm going to wrap it up, and if you have any questions, let me know. If you're stuck on something, please ask, and if you have another tutorial you'd like for me to work through, then please let me know. This notebook is shared. I shared it in the Discord channel, so you can access it and look at it yourself. Feel free to use it if you want to just copy and paste my code into yours situation. That's totally fine. That's the purpose of doing this kind of thing. The only thing special I ended up needing was the glob function. Everything else we ended up defining within the program itself. So that's pretty cool, I guess. Okay, well, that was useful for me anyway to work through. So hopefully it helps a little bit. Yeah, here it is. All right, well, I will sign off. I will see you all maybe Friday, but definitely I'll be back on Monday with another stream. If you have a request for a tutorial, please let me know. Okay, bye.